through this ACT math question from April 2021. It's question number 56, and it says a random number generator that generates an integer 1 through 6 will be used 15,000 times. Each time an integer is generated, the number will be recorded. Which of the following descriptors will most likely characterize the distribution of the 15,000 recorded numbers? So this is going to be a statistical based question. Notice it is number 56. It's near the end of the exam, and so it's usually going to be a little bit more complex, but it's not anything that you can't handle. So let's review a little bit about statistical distributions. And as we're doing that, I think if I was going through this question and looking at it, I'm going to use some information in the question, but then I'm going to go through each of my answer choices and see what makes sense. Okay, it's important to note that this is a random number generator. And what it basically is doing 15,000 times, it's going to randomly pick out an integer 1 through 6. 1, 2, 3, 4, 5, 6. For 15,000 times, those numbers are noted, and they're going to look at what kind of distribution comes of that. So what's important to note is knowing about a random number generator, each of those 1 through 6 options have an equal probability of being generated. And that's what uniform means. It is a uniform probability that they're equally probable of coming out as one of the options in the generator. So that's going to make E our choice. It is a uniform distribution. But let's make sure we understand the other options. When we look at answer choice A, bimodal, when we see bi, we should think 2. And a bimodal distribution has 2 modes, these 2 maximum values there. And that doesn't even make sense for what we're doing with this random generator. So that's not even going to be an option. A is out. A normal distribution is something that sometimes we hear about quite often, and that's that bell curve, right? Where it's symmetric. You have an equal amount of values to the left as you have to the right, and we have this center mean value. Well, that's not necessarily what we're getting. If you think about randomly, you're getting 1 through 6. There's not an equal probability of this value as there is this value. There's more of this value here than there is of that. And with uniform, we have an equal probability. So we're not going to have B as an answer choice. Okay, so for C and D, we have skewed left and skewed right. And for skewed left, you've got more of the results over here on the right-hand side. Skewed right, we've got just the opposite of that, more over here on the left-hand side. And that really we wouldn't have any reason, as long as we've got an equal probability, it's random, a random number generation, we shouldn't have any of that going on either. So one other thing I wanted to point out about a random number generator, in addition to it being from a uniform distribution, it's independent. And that's another thing to think about. When I generate one value and then I generate the next value, these two, the result of the second one is not related to the results from the previous. It's almost like you begin brand new. And then our next value is going to be independent of that. So those are 2 properties of a random number generation: uniformity and independence. And you can get some more practice with questions like this, or at least some more information on being able to solve questions like this, by looking up statistical distributions and just getting a general feel for the different types of distributions. This is your math question of the day. We have lots more videos to help you prepare for the math section of the ACT. Subscribe so you'll get our next practice. Until then, practice a bit more on your own, and when you take the test, you'll be glad that you did.